Привет, остров. Hello, everyone. Welcome to the. I have no idea. Do stream of making of yet another CCTV framework. Um, I've been streaming a lot lately. For some reason, I have no idea. I just have to a lot of energy and want to make a lot of stuff. And today's stream will be in English, mostly. Not today. Like I had another stream today's morning, and this one is like second stream today. So this stream will be mostly in English, and I will be probably switching to bits of Russian from time to time, but main language will be still English. And so this project is to make a thing that I've been looking for years. Basically, from time to time, I have this. How do I say it? Привет, Кощей. I have this потребность. How? So from time to time, I need to install some CCTV cameras for to monitor some locations, and what I'm always looking for something. So I need full HD cameras, just a few of them usually, and I need to basically just detect movements and store only only video from parts where movement happened, or possibly like movement in some area. And I also need this to be super cheap. Like I don't want to buy any special hardware. I don't want to buy any special like CCTV servers or like expensive hardware that would be able to decode, re-encode, or like store these streams or whatever. I just need to get some old PC from like 15 years ago or something, and just plug a few full HD cameras into it and let this work. And for some reason, there is no such project, like at least not such open source project, and honestly, I haven't found any proprietary solutions either. So yeah, this was a short introduction of what we will be making crap, basically. So the idea that I want of the project that I want to make is really super stupid, super simple. So what we have here, so let me show you, like, this is a camera. This is I'm not sure like whether that's full HD or just HD camera. We'll see what resolution it gives. And this is an Ethernet port with power over Ethernet, PoE. This is also like power, but this is not really needed. I can switch it on just by using PoE switches. And this camera will give its video feed using, it will be already encoded in H.264, like 264. This will be, the stream will be already encoded. So the idea of this super simple project is we have a lot of cameras, like many of them, and they have this already encoded feed using like RTSP, which seems to be standard for these cameras. And this feed will be there's some box that is like dedicated server for this CCTV crap. And the idea is that we don't need, like, why do all these servers need to be usually like solutions that you can buy or like you can install or whatever, they require you to have really powerful servers. For this reason of them, like they will decode all these streams, do something to them, and then re-encode back. And this is a lot of processing power, and this is completely unnecessary. You don't really need to do that at all. What you need to do, like the only thing that you need to do, like for most of the users that you not you like that that I need to do, like basically my needs are to detect movements and store like this. So what I propose to do here is that we have this stream. This stream is it has a lot of like different type of packets, and what we'll be looking at just at keyframes. These like I packets, as far as I remember, they are not that frequent. Like 1 per second is like a general estimation of them, or so. Like, so it seems like those are the frames that encode basically the entire. That should encode the entire picture for and other frames are deltas to those frames. And you, when you seek to video, you also like seek to some keyframe, and then deltas are computed from that. So yeah, what I propose is just from this stream so there are a lot of packets, a lot of packets, a lot of them, and some of them are I packets or intra they called or something. Those are like P or like B or whatever. Like there's a few types of those packets. Like some detail is that I don't really remember proper names of these things, so I will be, and like maybe I misremember some details, I will be figuring this out on stream. So you can correct me if I say something wrong. So the idea is we just extract these keyframes, and we do motion estimation, like, or motion detection only between these frames. Like we completely disregard all this crap. We could actually maybe we could try to detect motion using estimation of sizes of these packets. Like if nothing happens, maybe the delta packets will be really small. But that seems to be too difficult to do, basically because a lot of these cameras will have a lot of noise. So you will have actually really dense stream of information that you don't really need. Like you will have a dense stream of noise that you will actually filter out when you are doing motion estimation, not estimation, like motion detection. So, and this should be like super cheap. You only decode like 1 frame per second and not like 60 frame per second or whatever. And you basically this will allow you to have a lot of cameras. Like if you can handle only a single camera with like 30 frames per second for some hardware, you will probably handle 30 of these cameras on the same hardware using this approach. And there's like asterisk and like small print, because maybe decoding these keyframes is actually more expensive than decoding delta frames. So maybe you will have like half of the capacity, but still this is not a single camera. This is a lot of cameras. Yeah, this and another super simple optimization and the approach to all this crap is that you don't actually need to, like, if you don't decompress this stream, you don't actually need to recompress it back. So you just you just don't do anything. If you need to store some portion of the stream, you just dump it directly to your hard drive and be happy about it. Like, this is all you need. Like, what the hell, people? Why do you, like, green code, decode, or do this crap? If usually, like, these CCTV servers, they have functionality like adding some text, like current time or some other data onto the video. But this is, like, also complete garbage. You could have the same data just in, like, subtitles or whatever. Like, make another how do they call it? Not stream or section stream, maybe stream, like of subtitles, and just edit there. Or there are several types of subtitles. Like, do what anime, like, weeaboos do. Add some ASS subtitles. Actually, this probably isn't possible. I have no idea whether ASS can be packetized. But yeah, there are still options to do. Okay, so we have this. We have motion estimation, motion detection, and if we detect some event that says that we need to capture, so for example, this frame is, like, detected something. We basically have a window of, like, a few seconds before that, and we store this, we dump this, and until the next frame that said that we don't have any motion. So this is dumped, stored somewhere, and can be accessed later. That's it. Like, this is usually 90% of the functionality that I need for surveillance. Another thing is, like, for some reason, all of the open source CCTV packages, they are, for some reason, they are really, really old. So they have some crap like motion JPEG or whatever, which is, like, completely unnecessary. You don't need to do that. This is complete garbage. And they lack, what I need to have is, like, give me a simple HTML5 video page with video tag. Like, and just dump this stream to this crap, and this will work almost everywhere. There are small details about, like, format that cameras give out, maybe not really supported by, like, mobile hardware or something, but that I'm willing to either, like, I should have been streaming in Russian. I'm willing to tolerate that, or I could, like, for this functionality, I could implement a simple, like, ffmpeg command to re-encode this requested stream or on the fly, because that could it's possible that this is not compute intensive enough to, like, to affect anything. Okay, so this is basically the overview of the project. So we are going to make this little C program using FFmpeg libraries that will get the RTSP stream from some cameras. So this is cam 0, this is cam n. It will get keyframes. It will feed to something that will detect motion. I haven't thought about it yet, but there are many possibilities. Like, basically, we could like even write our own like really simple and stupid motion detection, or use existing libraries. It will buffer this data and dump it into to the hard drive when motion is detected. And it will also be able to pipe this data to FF server that can feed video stream to HTML5 page with video. So yeah, that's it. Sirenius, hello. You can read one stream on Intel QuickSync. I have no idea what's Intel QuickSync. What is Intel QuickSync? These are other projects. So the thing is, I probably don't have Intel QuickSync on hardware like this. And this should be pretty much enough for the for thing that I'm saying. That was Raspberry Pi, and it can it has hardware to decode or encode H.264 streams. But I think it can only like either decode or encode at once. I haven't actually tried like doing this in parallel. And I mean like full HD streams. So yeah, I also don't have this on AMD hardware, and this also AMD hardware has its own like alternative there, like VA API using like libva or something that also has like hardware decode and encode abilities, but there are like some issues with it. Okay, so what I need to do here is libav format docs. Let's find out how to write. This is a great documentation. Like, I don't see anything that I could possibly learn from this. Official documentation. Libraries. So this is like this API. Okay, API. What do you need? A format. Examples. What's filtering video? Remuxing is also what I need to look at. Okay, these seem to be the thing. So what I need to do is I need to open RTSP stream, which I believe is done using AV format. And then I need just take packets from there and like find a video stream and take packets from it and detect whether the packet was contained keyframe. Maybe it's a bit more complicated than that, but this is the purpose of the streams, like to figure this out. So what they do here, they open input using like file name, which is a stream. Probably I can just pass RTSP stream here, RTSP URL, find stream info, output context. Okay, maybe this I don't need at the moment. Maybe I will need to, but basically what I'm doing is just this remux stuff with a bit of logic, a bit of filtering logic added into it. So it goes through all the streams, create the output stream. So there's some codec data, okay. Dump format. Okay. What is AVIO? I have no idea what that is. Okay, we'll figure this out. Right, header, okay. And then read frame. What does read frame do? Maybe it does read like packets. Streams, packet stream, in stream. Okay, we need to consult the headers to figure this out. Stream index. Stream mapping size. What? Привет на минус. This is interesting, okay. AV. So yeah, that's basically it, but at some point, so when we get packet here, we need to figure out whether that was a keyframe, and then we need to decode video. So we need to decode this frame to get an idea, to get our motion detection thing going. So again, why are you explicitly looking for MPEG-1? Decode frames. So yeah, this I actually worked with FFmpeg a few years ago. Not a few years, like it was 10 years ago. And I remember thing like you can feed it packets, but you not necessarily receive, like there is no packet to frame correspondence. It should be for keyframes, at least like you can feed it like single packet for iPacket, and then like feed like I don't have anything else, and then it will give you the frame, decoded frame back. We'll need to like experiment with it a little bit. Okay, and yeah, another thing I wanted to show you like how this works, how this camera works. So this is a camera, and this is like it's powered using power over Ethernet, and when you like switch it up, plug it in, yeah, should be like this. Yeah, so it will initialize for a moment, and then these cameras, like this digital HD, like RTSP encoding, like H.264 encoding cameras, are really cheap, like a few dozens of dollars or something, like 3 maybe. Like there are a lot of, like, it depends on like model, but it's cheaper than $100, or like it's cheaper than 5,000 rubles. They are not like super cheap, like not dirt cheap. You can't like buy them by kilograms or something, but they are not like outrageously expensive as professional solutions that a single camera can worth like a few $100. Okay, so I think it has initialized, and I need to figure out the URL for it. They are vendor specific. They are not. These cameras like have some crappy firmware. They are usually Chinese, and like they don't have anything. They are super unstable in that sense. Their like control panel is broken, and they don't advertise its URLs properly, and you just need to figure out this by using internets. So this is some camera branded as Vesta in Russian, like just a branded and subgeneric Chinese camera. So Vesta RTSP URL usually like goes like this. Yeah, something like this. And I actually tried this camera before just to make sure that it works, so I remember the IP address that it should get. Okay, so I have the wrong. Okay, I need to this URL into. So yeah, this is me. And there are slight delay, but you can see that like this camera works. You can look at it at yourself. Okay. So this is the URL that I need to feed into. So yeah, okay, let's start. Let's code this shit. I will be calling this project Zenki, because that's a Russian slang word for ice. And I love like stupid project names. I'm really happy about it. So yeah, maybe I just need to okay, or no, I will start coding this crap myself. The Atlant books. Okay, that's nice. We'll start with main. And although I think I want to have this side by side with my source. So yeah, main RGC RGB. Let's just dump what the format that we get, the packets that we get, to get the idea of what we have here. And we'll probably need to do a few things. We need to have a format I'm not sure about AVutil, but we'll see. So in CTX, no. They do have like log packet. Okay, okay, they already have this. But yeah, let me write it myself. So basically what we need to do is AV format, open input, pointer to pointer, URL 00, and I'm already interested in what these zeros mean. AV format network unit. Optional, not recommended anymore. Okay, that's great. I believe we also need like to do some initialization here, like register some crap, but maybe they do this automatically these days. AV format, open input. What? Input format. Forces, no, we don't need that. Mixer private options. Okay, we don't need that, and those are pointers, so let's make this a little bit more readable. User supply TV format context. Oh, okay. And this is like a huge structure. Format data. What does filtering video do? So yeah, it can apply something like rescale, and so yeah, we can do video operations, video modification using this, but yeah, we don't need that. Okay, so we open the input and we need to char URL RGB 1. We only support one. If RGC less than 2, like printf usage TSP URL. RGB 0. Oh, I wonder what does it return? AV error on failure. Okay. URL red. Exit. Okay. Red AV for format find stream info in CTX 0 what find stream info find stream there's options what okay, we don't have any options and this is a pointer. Not find stream info. Could not. What does this AV dump format do? Do we have it here? What is this function? Utility function. So this is actually from util. Right? Index of the stream. Maybe we should like iterate streams. Stream AV stream and number of streams. Is that stream or is this something else? Yeah, maybe we should like iterate. What was the type there? Unsigned int. Printf. Just we will dump a lot of stuff just to get an idea what's going on. NB streams, and we also need to have this as unsigned and define log like this. I think I don't remember the exact syntax. Message, then this, and then VA args. I think that should be it. So the sole purpose of this log stuff is to cut this crap. And this. in CTX streams and dump all of them. AV dump. Moment. In CTX index URL this is an input. Okay, dump all of this. Some separator just in case. Have no idea what the format will look like. Output context we don't need. Stream mapping. This we don't need at this moment. What we need is to read frames from this. So we'll have this for forever loop. We will read packet. What to do if we fail to read the packets? Oh, okay. Okay, so packet has like this stream index. Let's just dump all the data on packet we have. AV packet. I need to find AV packet. PTS, DTS, data size, stream index, flags. Okay. Keyframe. Okay, we have this information here. Great. Packets. LLD. So let's just print all this crap. PTS, DTS, size, stream, flags, duration, pause. PKT, PTS, packet, DTS, packet size. No. Packet size, packet stream index. That's it. Need to if in CTX input You also need to be pointer to pointer for some reason. Stream and yeah, that's it basically. We don't need to do anything else, I believe. Do we need to do something with the packet and ref? We need to do packet and ref, of course. Do they have anything else going on here? VTS. Okay, well, I will print raw data here, but these functions to make it more readable. Okay. And now we need to compile it, and for this I will also reuse my make file from open source. What did I do? I just desynchronized video with okay, let's hope it works. Today's stream is super lonely. For some reason I don't have enough people in the chat, and yeah. Make file. I don't need all these. There's no. This is not OpenGL. I don't need any of this crap. Debug. Okay. This I don't need. This no Raspberry. Maybe I will need Raspberry at some point. I don't need any of this. I don't need any of this. Привет, Arsenij. Not long, okay. And all I need is main C. Obsteer Zenki. We do need to link with AV format, and how do I do this? So here's make file example. Yeah, that's basically it. That's basically what I've been looking for. C flags. And yeah, cctv3. As I was saying previously, like I found this thing not that long ago, and it will contains a lot of debug data, like up to micro, which is really cool. AV format. Maybe that's all we need, but we'll see. For now, like later we will need a lot more. Shall config flags. This should be enough, I believe. Right? Math, yeah. Do we need math here? Or threading? I don't think so. What? What? Platform config compiler build gear. This is weird. Hmm. Okay, maybe I have no idea what's going on. What's just main C, right? I don't have anything else. Ah, the space. Before string constant. Long int. Okay. C99. Okay, let's look at this. Did I? No, I had it here. So okay. Uh, this is what I need. I just forgot about this, so I need to do this and this. Right? This is... did you know that on Windows, long is 32 bits? And this will break on Windows. AV packet and ref. AV packet and ref. Привет, Павел. AV packet. So AV coded. We already using AV coded. Okay. Okay, so let's try feeding it real data. Where was my URL? It was here. What? What? Okay, let's look at documentation. Open AV error. AV error. Patch welcome. AV star error. Error of stray. Okay, so we need to link with another library. AVutil. Protocol not found. What? You do have this protocol. I believe we do need to register all this crap. We register all. Yeah. So we have a lot of packets, and we sometimes have packets 1, which you remember are keyframes, and those are larger than other packets. So this seems like a good sign. And those times are weird. Did we dump stream information? No, one stream 0, input 0, render speed, video, progressive, full HD, 20 frame by 5 frames per second, and I have no idea what this is. This was deprecated, right? Okay, I can do this. I have like AV format network init, whatever. So yeah, this. And I have no idea what to do next. So let's look at examples and figure out what do they do. Did I close my packet? Yeah, so this is packet. So decode example, what do they do? Why do they allocate packets? We don't allocate packet here. Okay, whatever. So when we have a stream here, AB stream, we have a codec parameters, time base, data, starting duration, disposition, discard. Maybe we can specify discard at this level. Non-intra frames. So yeah, intra frames are keyframes, right? Or no, I forgot all the terminology. All frames except keyframes. Event flags. AV stream. What? That's it? Okay then. Frame rate, codec parameter, codec type. This is probably what we should do. find decoder. I don't think we need this. Codec ID. And here we don't have codec ID. Codec ID, we have this one. Okay then. We do have codec. Then AV parser. What does AV parser do? Codec context. That's also a thing. So we find as like codec class. Then we allocate context for this codec. Then we open, like, create an instance of this codec. We don't use parser. Oh yeah, parser is for something else. We feed this. Here they don't open the file using AV format, right? They open using, they use AV parser. Read like something, feed this into parser. Parser fills packet, and then we feed this packet into decoder. So yeah, the only thing that we need to do is send this packet to the decoder and then receive frames from decoder. I think that's the idea. So okay, I've been streaming for an hour. I will make a short, like 3-5 minutes break, and will return to decoding frames. You know, it's super difficult to stream in English for some reason. Maybe I'm too tired and I shouldn't have been streaming like for 4 days consecutively. Because like streaming English makes me think a lot about what I'm saying, and this is really tedious. Okay, so decoder. So we need codec context, const AV codec. This is a pointer. AV codec context. We don't need parser. We need. Okay, so at this point we did find stream info. Stream ID 0 to do set this not ID, stream index. So what we do here is we try to find codec based AV codec, find decoder for in CTX streams, stream index, right? Streams, stream index, AV stream codec per. This is a pointer, right? This should be a pointer. Yeah, this is a pointer. Codec par, and also codec ID. If not codec, then well, codec. Can we name have a stream name for this? Probably not. I don't see any functions that give string names for this. Maybe that should that is in AVUtil. How to Google for AVUtil? Modules. Util. Util. util, mathematics, memory management, structures, video related, error codes, login further, stringify no. What is this? AV AV codec string maybe. No, this is something else. Okay, this is completely weird. AV codec ID to string. AV codec get name. Get name. Yeah, this is it. Const AV codec ID. Yeah, we added AV codec context, and we should probably deinitialize it if AV context. How should be destroyed? Example. Find decoder, parser needs. We'll get there. AV codec log context. Do we have 4? Okay, and next one is AV codec open. Open to what? Предыдущий проект к cctv никак не относится. Okay, open2 is the current function, so we need to pass in codec context, codec options. We don't have any options for it. Different less than 0, then And here I need to do two things. First is this. And second, test dev, привет. Second thing is this. Probably I should have this as a macro or something. Stray. Okay, we have opened the codec, and then AV frame. So we need to allocate frame, right? AV frame. Okay, allocate frame it is. What is a frame? AV frame. Okay, that's a lot of data. Audio samples, keyframe, picture type, sample. Okay, you know what? Whatever. AV lock. What? You don't have a lock frame? No lock frame. What? AV frame lock. Okay. AV frame lock. Do we actually need it to be like this? Maybe we can do it like this and we'll see. Список нитов, которые не систем D. Busy boxing. This is interesting actually. Process supervision, rollback, and socket activation. Also kind of interesting. Thank you for the link. This is interesting. Will this concept handle other input devices such as capture cards, for example, just for fun? You mean like my current project? I don't think so, but so it's out of scope of what I want to do. What I want to do is to make this specific, really specific thing where I can buy a lot of cheap Chinese Ethernet cameras that have their own hardware encoder, and I can just store their streams and detect motion on those streams. But as you probably know and probably don't, because I didn't know that before like a few months ago, there are actually USB, for example, there are USB cameras, like web cameras, that also do hardware encoding. And I mean like 8264 encoding. And it's completely possible just to replace this AV format thing with some other source of, but not actually. Yeah, it would be possible to get that and pass it into, I believe, this AV parser thing, which will packetize, I mean like AV packetize this stream, and it will have these packets where you can detect whether that's a keyframe or not. Maybe that can be done. So I guess I will eventually modularize it, so you will probably have we will have possibility to add different modules, like replace this RTSP source with something else. But at this point, it's just a proof of concept. I'm trying to. I will feed it with a few cameras, and like in production, I mean, not on stream. On stream, I will be working just with a single camera probably, and we'll see whether that solves my problem. And if it is, I will probably develop this project a little bit further. Okay, so I have a frame. And I have a packet. And if this packet has AV packet, AV stream, AV packet, AV packet, AV packet flag frame. Then I will feed it into the decoder, which is AV codec send packet. This is codec context, and this is packet. And this is red. If red is less than 0, then we should print a lot of data here. So yeah, that's this. And then we also need to do this. AV codec receive frame. Okay, so if we need to basically so if this end of stream, or like I don't have any frame for you right now, we just break. And maybe we should write here like we don't need to write anything here because this will be a lot of this will basically spam our output, so just skip this. If red is less than 0, then this is an error situation and we should probably handle it like error, and otherwise we should just dump our frame. So let's just dump the data on the frame that we have. So frame, we got a frame. AV pixel format. From AV pixel format. Okay. AV pixel format. Can I have these like to them fast? Quest.bofa? You mean like bocha maybe? Or I have no idea. Hello by the way. Do I need not really, this is a single line break. This is fine. Picture type. Picture type. What is picture type? Type. Okay, I will print it like this. Aspect ratio, I don't know. Quality error. Sample channel layout. AV extend what? AV frame flex. Rub discard. Flex. Okay. Color range. Color space. Location. Metadata. Channel spec size. Okay. What do they do in this example? Frame width, height, data, line size. How did I miss that? Okay, width, height, and stride, line size. AV non-data data pointers. What is this? So there, this for multiple planes. Okay. AV pixel format to string. AV get pix format name. Okay, this should be enough data. Do we need to do anything special with the frame? I don't think so. We only need to like AV codec free context. AV frame, if AV packet, we don't need to do anything about this, I believe. Or maybe we do actually, because like when this when this received frame, it allocated everything inside frame. I should move it somewhere else later. AV frame and ref. AV frame and ref. So we need to do this, I believe. Okay, let's try this. AV codec ID, because we need lib AV. This probably need something else too. This is not enough. Okay, AV code. Not here. AV codec ID. AV code. AV codec. What are you? AV codec ID. Why? Why? No. AV PKG flag. Key, and this should be just key, not keyframe. Key. Maybe get pics format. Yes. Get pics format name. Get AV get pics format name. AV get pics format name. This is it. AV util. Maybe I need to. What? Util. Maybe I need another order of headers. This is weird. Okay. No, nothing. Non-type name. Maybe I need to do it like this, right? Yay! Okay, and we got segmentation fault. That's great. Okay, this happened in its thread, and we have no idea what's there. This actually happened after first keyframe packet. But we could check our thread. AV frame unref. Okay, so you don't like the frame unref thing. Let's not do it then. AV buffer unref. Okay, maybe we do need to allocate frame. What are the alternatives to this function? To initialize frame internal structures without allocating the entire frame. File enumerations, functions, frame, frame unlock, frame free, frame clone, frame unref. Frame copy, frame. Okay, probably it's easier to just allocate it and then free. Okay, but what we don't see any frames. We don't see any frames. packet size. And we need to zero that. Because we are not skipping anything. Also, this and flush. Send resource temporarily unavailable. What? So you don't like this? Okay, that is unfortunate. Next delay reach needs to consume packet. RTP. Interesting. What do I do wrong here? Okay, let's Google it then. AV lib AV codec decode only key frames. Okay, someone actually was doing really similar to what I'm doing right now. Interesting. So stream can specify that you shouldn't output this frame at this moment. Thread decode and delay between. Okay, maybe thread type. No packets until you do get the decoded image. What? So giving it a null packet actually means that we are ending the stream. Hey Alkama, how it's going? I'm not doing any Damascene stuff today. I saw you streaming some shader stuff today, but you ended the stream before I was able to write say hello. Give me a picture if it's decode video. What is decode video? I mean, like, your scene was. It's sad to hear you that you're sick. Get well soon, but your scene was like really. It wasn't really complex, but it was still interesting, and I just wanted to say hi. And coding when sick is not really productive, but for me, it gives me an opportunity to not focus on sickness. I guess. Um, okay, so this is if this is not a library function. Let's look at these functions in more detail. It's hard to concentrate to do anything like complex, but it's okay to do something playful. Yeah, shaders and music stuff that can be done like while sick. If you are not learning anything new, I guess just playing around. Raw packet data isn't to decoder. What is this? Codec open 2. Do we do this? Yeah, we do exactly this. Current state. User must read output with AV codec. Receive frame. Packet should be resent. Once all out. Okay. This doesn't seem to be there. Okay, this is a mistake. This is a mistake. And we get a segmentation fault. But where do we get it? And strlen 5 Okay, GDB failed, crashed itself. Okay then. This is actually interesting. so you failed at this because you maybe some of these things here are not correct. For example, this one. For some reason. Okay, so this is not related to our to whatever we are doing, at least with packet stuff. So yeah, we do get a frame for each keyframe. With format 0 for some reason. Format 0, what does format 0 mean? What other fields we see? We see flags. Why they keep this is a key packet. Picture type 1. Picture type 1 is intro, I believe. Yeah, this should be intra. Keys, this is keyframe. That's okay. Flag 0. Format. Yeah, format. Pixel format. So this one. Okay, this we can work with this. Why not? But I mean, like, what do people here do? Do you do anything interesting with format? You don't. Okay, so we got frame. Let's test that this frame is actually valid. I'm just reading like what the data details on formats here. So this is paletted format. Okay. RGB. Can I force format? To be something. Resample. So yeah, probably we need to do a filter to decode into different format. Okay, interesting. We have scale and PP scale and interleave, precise. Yeah, filters. move this out of the way. Okay, so this works. This I don't need anymore, I guess. Okay. Encoding set by user, decoding set by user if known, or written by while person. Okay, so I can't force this. Get format, negotiate, nominal unaccelerated. Okay. So yeah, I can't do anything about it. So I guess I have two options. Option number one is to try to work with whatever format I've given here and hope like that they all will be something along these lines, which is also not really great to work with. Or add a filter to convert pixels to RGB. Okay. Okay. Let's look at examples. Do they do anything interesting here? Decode video, demuxing decoding. What does this do? So they okay, raw frames are written. So it actually opens file by AV format, find stream info, codec context. Find the stream, find decoder. Why do you do this? This is bad. Don't do this. Find decoder, allocate context. Parameters from input stream to output codec context. This we didn't do this. Let's see whether that changes anything. This is actually interesting too. So AV codec. ST is stream, right? AV stream. So yeah, this is in CTX streams stream index. And as usual, if we have something wrong, AV codec parameters to context. Whether with or without reference counting. Interesting. Where do I read for all these string parameters? I have no idea. Just reading sources, I guess, for these libraries. What strings do they check for? Format. Frame alloc init packets. I also didn't do this. I just started reading frames without initializing packets. Okay. Stream. Okay, decode packets. So they also like read packets and decode packets. While packet size. So packet can contain more data than like one frame. This is interesting. Okay, and we can have special effects like changing frame resolution between different frames. This is interesting. This seems to be the outdated function. AV image copy, maybe we could use that. Maybe we can change pixel format on this one. Decoded. Packet size. Do you update decoded anywhere? This is interesting comment. So I guess for video, each packet is a single logical unit that cannot be divided further. But there are audio codecs that read only portion of the packet, and we need to feed the same packet sometime soon. Also, some decoders might read the packet. Okay, whatever that means. And this is interesting. Like this is seems like a super esoteric example. I haven't heard about this codec. Okay then. AV image copy. Image copy without conversion. Cacheable memory, copy plane, image lock, image full point, line size. Maybe there is a function too. Okay. What filter as word sample? What does this function do? Oh, library. Format conversion, type of samples, audio. Okay, this is not what I was looking for. This is not needed. Scale. This one. Image scale, color space, pixel format. Yeah, this is what I need. Scaling video. Scale and context. Okay. So yeah, this is basically it. And I need these libraries with scale. And then image lock, source destination. Source data, source line size, source DST data, DST line size. You know what? Let's first check the. Let's just dump this data into raw file and as current format. Remuxing this one, we had something like this here. Image copy and then null-aligned data. Okay, you know what? It's 1 a.m. here and I'm too tired. But yeah, today we could do the thing. We checked the hypothesis that we can get keyframes easily, quite easily, using the libav format. We can decode them. Hopefully, we do see that we get frames, but we haven't actually checked that these frames looks like anything. This I will get to next time. As for now, thank you for watching, and we'll see when I will be able to stream again. Thank you. Bye.